Okay, so today we're looking at vector equations of a straight line. Now, learning intentions to gain the knowledge in writing a vector equation of a straight line in 3D space. Some things to remember and to be successful. X squared plus y squared plus z squared equaling a constant. In 3D space, that technically is the vector equation of a plane, not a line. Yeah. To write a vector equation of a straight line, we need to write it in the form of a vector A plus some scalar of vector B. And that's the form that we write it. We need to be able to convert things into parametric equations. Now, we need to know that depending on the lambda of our vector B, if lambda is less than 0, the new point will lie to the left of A. If lambda is between 0 and 1, it will lie between A and B. If lambda is greater than 1, it will lie to the right of B. So we need to be able to also do a parametric equation of a straight line, being A1 plus lambda B1, y equals A2 plus lambda B2, z equals A3 plus lambda B3, or the Cartesian form of a straight line, being lambda is x minus x1 over the difference, equaling y minus y1 over y2 minus y1, the difference, the change, and z minus z1 over z2 minus z1. Alright, so in 3D space, if we have a position, if we want to have this equation of this line, we have one position vector, which we call A, and then we know another vector B, right? So the sum, or the vector equation of all this line that points to this is going to be some lot of this vector plus a magnitude change of this vector. So if lambda was negative 1, the new point will be somewhere here. Yeah. If lambda was between 0 and 1, it would be between these points. But if lambda was greater than 1, it would be to the right of B. Yeah. So the equation of the line will point to all points on this line. Yeah. Let me write it as R equals vector A plus lambda vector B. If we want to find an equation of a straight line when we're given 2 points, what we're going to do is going to calculate the difference from point B and point A to give us vector B, and then we'll be able to use the first vector to find the difference. Now, vectors are parallel if they're a scalar multiple of lambda, and if they intersect, we have to do some simultaneous equation examples. All right. So what is the line through the point, and it's going to be parallel to this vector? Well, let's say that's your vector A, and you want to be parallel to this vector B. Well, the line is going to be the point plus some lambda version of B, which is 1, 2, and minus 1. And that's your answer. If we want to write a vector of a line through these 2 points, so we're going to let A be the point 6, 2, and 5, and B be the point 9, 2, and 8. Well, then vector B is equal to 9 minus 6, then 2 minus 2, and 8 minus 5. So that's going to give us 3, 0, 3. Yeah. So the line will be the position vector of A plus some lambda of our vector B. So 6, 2, 5 is our position vector plus some lambda of B, 3, 0, 3. Okay. Here we've got an example. We've got line 1, line 2, and line 3. We want to show that line 1 is going to be parallel to line 2. Well, in line 1, right, we have lambda represented by t, and that's 3, 6, negative 3. Okay. In line 2, we've got some lambda, which is represented by the letter S, of negative 2, negative 4, and 2. So the one thing I would probably want to do is probably try to have something in forms of ones. So if I took out, let's say, negative 2 from here, I would get 1, negative 2, negative 1. Okay. And here, if I, let's say, I took out 3, that would be positive 2, negative 2 times positive 2 is negative 4. Yep. So if I took out 3 from here, I would get 1, 2, and negative 1. Okay. So here we have 3 lambda, and here we have negative 2 lambda. So lambda is, in respect to each other from line 1 and line 2, is, so from, let's say, from line 1 to line 2, is negative 2/3 of each other. So therefore, the vectors are parallel. Okay, we want to show that line 1 intersects with line 3. So the way to do this is we're going to write the equations and kind of match each part. So let's say 1 plus 3a, right, the top line, that has to equal 3 minus b. So that's saying that would be b, so minus b. All right, we'll call that equation 1. The next line I get 2 plus 6a equals negative 1 plus b. Equation 2. The last line, so my z values, 1 minus 3a is equal to negative 1 plus b. Equation 3. So the first thing I'm going to do, so that's making the equations. And then what we want to do is we want to find a and b. I'm just going to use 2 equations for that. So I'm going to do a simultaneous equation. Okay, so if I if I add the 2 equations together, I will kill the b off. So equation 1 plus 2. So 1 plus 2 is 3. 3, that gives me 9a. Plus gives me 2. Plus gives me no b. So 9a negative 1. Okay. Sub a equals negative 1/9 into equation 1. So 3 plus 1/9 minus 1. So I actually get 19/27. Sorry, that makes no sense. All right. I'm trying to find b. So 1 minus a third. So that's 2/3 3 minus 2/3 is 7/3. Okay, so I've got an A and I've got a B value. Now we're going to, using our new A and B, we're going to plug into equation 3 and test the validity. Okay, so left-hand side, we get 1 minus 3a, 1 minus 3 lots of negative 1/9. So we get 4/3. The right-hand side, we get negative 1 plus 7/3. We also get 4/3. Because the right-hand side equals the left-hand sides, then line 1 and line 3 intersect. Okay, and that's how you test to see if points intersect in a 3D plane. Okay.